Right, for the AQA students, today we're going to just have a short lesson on HDP and LDP first. So high density polyethylene and low density polyethylene. So remember, polyethylene is simply when the N, so the ethene molecule here, turns into polyethylene. That's it. That's what we're talking about. We're only talking about this particular polymer. So don't confuse this and this. They're actually different things, even though it's on the same page. This is talking about all polymers. This is talking about only polyethylene. So it really is fairly simple. You need to know the conditions used to form either the high density or the low density version and the special property that arises of each. So if something has a low density, then it cannot pack very well together. So there's not as much of it in a particular volume of space. So if you look at this picture here, which is the LDPE, can you see how there's branching? Now the branching means that the chains cannot pack closely together. So that makes it a low density because it takes up more volume. If it doesn't pack as closely together, the force of attractions between the molecules are weaker. So it has weaker intermolecular forces between the chains. So it is less strong. And it has a lower melting point because less energy is needed to separate these weaker forces. It has less or weaker intermolecular forces. Now, HDP would basically be when the chains pack closely together like this. So then it will have stronger intermolecular forces as a result, making it stronger with a higher melting point. And the reason it is more dense is because it can pack more closely together. That's pretty much it. Then how to form each one. So for LDP, you need to know that you need a high pressure and a trace of oxygen. And for HDP, so this is when you take your ethene, basically. If you apply high pressure with some oxygen traces, then you get LDP. If you get this ethene and you apply 50 degrees with a catalyst and a slightly raised pressure, then you get HDP. It becomes more closely packed. So the catalyst with the lower temperature and pressure, well, actually, this one doesn't say high temperature, it just says high pressure. But the catalyst allows things to happen at more ambient conditions. Okay, so that is what you need to know. You don't need to know the exact kind of values here. Just know this. Okay, so HDP is done at a lower pressure, but it's still slightly raised and with the catalyst. Whereas the other one is done with, importantly, a trace of oxygen and higher pressure. And I would still argue higher temperature. I mean, they both need heat. So I'll probably add high temperature to this. So in summary, LDP has high temperature, high pressure, and a trace of oxygen. HDP has a slightly raised pressure and a catalyst at 50 degrees. Okay, last section of this is the thermal setting and thermal softening. So again, this is for any polymer. So it can be for polyethylene, but it can also be for other addition polymers. So thermal softening, as the name implies, can soften when heated. So the idea is that when you heat it, it will soften. Now, this happens because the polymer chains are tangled and they have weak forces of attractions between the chains, and they have no covalent bond cross links between the chains. And by that, I mean, if you look at this diagram, notice how you just got the red one and the blue one here just mushed up together, whereas in this one, notice how the different colors actually have these bonds between them. These are called strong covalent bond cross-links because you're cross-linking two chains. In this one, the chains only bond within themselves. They don't bond to the other chain. So the thermal setting polymers have a strong covalent bond cross-links, which take extremely large amounts of energy to break. So they remain hard when heated. The only thing they might do is char or blacken. Okay, that's because soot forms. But the main thing is they don't get soft when heated. Obviously, if you put them, I don't know, at a temperature as high as the sun, everything will melt. but we're talking about reasonable conditions. So that completes the course on polymers. It's mainly just learning by heart how to form each one and what each one is. So I will see you next time for the final section of the polymers, which is the condensation polymers. See you then.